So this video is going to be about Algebra 1 Regents. This is a short response section. We are not going to start from the beginning because we have already done some of the questions already. So we are going to start with number 28. Let's just go ahead and start. Number 28 is the formula A equals, so basically I'm not going to read through the formula, it's just you see the letters there, is used to calculate the acceleration to the, so you know what guys, this is irrelevant. Everything here is literally irrelevant except one thing. Solve the formula for the final velocity VF. So this is what's important. That part is important. What we're solving for is important. What we're freeing of this fraction, what we want to be left alone, that's what's important. So how are we going to do this? I'm going to rewrite this equation. It's A equals VF minus VI over T. So in order for me to free the VF, the first thing that I'm going to do is I'm going to multiply both sides of the equation by T, thus killing the fraction. Times T on both sides. So it's going to be TA or AT, however you want it, doesn't matter, equals 2, and now there is no longer, so that T that we're multiplying by, it suicides itself with the T on the bottom. So now it's going to be VF minus VI. Now, how do we get rid of that negative VI? We're going to multiply, what am I saying? No, my bad. We're going to add VI to both sides of the equation. Obviously, we're not allowed to add AT and VI. So what's going to happen? We're just going to keep it like that. It's going to be AT plus VI equals to VF, and that will be the answer. Technically, it's just a two-step thing, and all we need to know is just what variable, like which part to solve for. This is it. VF equals AT plus VI. This is a very popular type of question. You can see a lot of these questions on the, like, let's say SAT, and it's just a good question to be able to do. Moving on, number 29. We're gonna do real quick. We're not gonna like spend a lot of time on it. So it's about basically throwing things around here and there. So the first thing that we do is that we're going to subtract 3/5 x from both sides, thus eliminating this 3/5 x. So it's going to be 1/3 less than 4/5 minus 3/5 is 1/5 x, obviously, minus 1/3. Now we're going to add 1/3 to both sides, thus eliminating the negative 1/3 from the right side. It's going to be 2/3 less than 1/5 x. And the last thing that we're going to do is we're going to do division by 1/5 on both sides. It's going to be x greater, and now 2/3 divided by 1/5. We're going to do keep change flip, obviously, and it's going to be 2/3 times 5/1, which is 10/3. And I think we can keep it like that, but this can also be rewritten as x going first, then greater, the open jaw towards the x, and 10/3. Either way is fine. This is it. If you know how to solve inequality equations, this is just like that. The only thing is that we have to deal with fractions a lot here. But I mean, all the fractions that you have to combine here have the same denominator. So I mean, it's not that hard after all. We're moving on to question number 30. Well, this is one of the I don't know, one of the gift questions, I would say. I would say rational, irrational questions are one of the easiest topic questions. So let's just do it real quick. Is the product of two irrational numbers always irrational? Justify your answer. The product of two irrationals, right? Is it always irrational? The answer is no, not always. Why not always? Sometimes yes, but not always. If we have square root of 2 times square root of 2, both of them are irrational. Is that right? That's right? But they're going to end up giving us square root of 4, which is 2, which is rational. So two irrational product, right? So it means multiplication, can be rational. But it can also be irrational. Just like if you multiply square root of 2 times square root of 3, which will be square root of 6, which is irrational. Irrational times irrational, irrational. So that's why they say always, right? Is it always? Not, it's not always. So this, I would say, would be enough for the explanation here, because explain, they said justify. Justify is not the same as explain. Explain, when they say explain, you kind of have to throw in a couple of sentences here and there. But when they say justify, this is justification. Moving on. Easy 2 points. Solve. So this is a relatively easy equation to solve just by the rules of solving equations. It's not that hard equation to solve. But basically, there is a way to get 1 point here and out of 2, and I can show where it is. So when do we solve for x? What do? We isolate the x. So we're just going to do just that. We're going to add 42 to both sides to start isolation. So it's going to be 6x squared equals to 42. Then the next step of the isolation is dividing by 6, which is going to give us x squared equals to 7. And now is the moment where you can get half of a point or a full point. So we know that a reverse section of a square is the square root. We're gonna have to do the square root here, and we're gonna get x equals to, and if you remember here that you have to put plus minus square root of 7, because we don't have to, they say exact. When they say exact, they want you to keep it like this. They don't want a decimal. If you remember that it's plus minus, then you will get 2 out of 2 points. If you're just going to put square root of 7 as the answer, you're gonna get 1 out of 2. As simple as that. This is a couple of steps. It leads you right to it. That's what they want. This question is made to check whether you remember this or not. Okay? Well, first it checks whether you know how to solve it generally, but basically the main idea here is if you remember that or not. Moving on. We're getting to a hard question, and that's actually the reason that I wanted to do this video. Because this is called piecewise function. And piecewise functions are generally not an easy topic. I would say in Algebra 1 terms, this would be like 9 out of 10, I would say. So let's see what we can do. And let me actually explain how the piecewise functions work. They actually do look scary, although they're not that scary. So since we have to graph, piecewise function is just two functions on the same graph. That's why there are two things here, like two equations. It's two functions on the same graph. So technically, you can split this into two separate thingies, two separate equations, like y equals 2x minus 3, right? And this, x squared minus 4x minus 5. The only thing that how piecewise functions are, I would say, can be harder is that they have boundaries. Like this is a boundary for this, and this is a boundary for that. Like invisible boundaries that don't let the graph to go anywhere like below or let's say or over. So this is like a double boundary. This is one boundary. Okay, so what we're gonna do, how do we graph that? We are like the best way to do piecewise function graphing is to do t-table, right? And the first thing that I want you to plug in is the boundary, the 0. If you plug in 0 for the x, you get 2 times 0 minus 3, which is going to be negative 3. And then I want you to plot it right away. Why do I want you to plot it right away? Because you won't forget like the thing that when you're plotting it, you're going to have to use an empty circle, because this inequality sign is an empty circle sign. Okay, so 0, negative 3, 0, negative 3 over here is going to be an empty circle. And we know that for a line, we need 2 points. So pick any number to plug it in here, but it has to be less than 0. Okay? And I don't know, negative 2. 2 times negative 2, negative 4. Negative 4 minus 3, negative 7. Okay? So it's going to be negative 2, negative 7. 3, 4, 5, 6, 7. And here you can already plug in the regular point and connect it as a line, as we do a line connection. This is the line. And the idea is that this line does go down because there is no lower boundary, but it cannot go up. If you do this, right, or like, you know what I mean? This is a minus a point. This is a 4-point question. You're going to get a 1 point minus, okay? So the idea of this piecewise function is the boundaries, that can you graph, but like this, but this specific equation, like let's say function within a certain boundaries, or you can't. Okay. So the next one is going to be the quadratic function within these boundaries. Same idea. You're gonna have to do t-table and plug in the boundaries here. So it's going to be 0, right? And what do you do with that 0? Plug it in here, plug it in here. Okay? 0 minus 5 is negative 5. And then, in order to make the best graph, I think you should just plug in all the numbers. It's not that many. It's like 0, 1, 2, 3, 4, 5. That's it. You cannot go more. So I'll do it real quick, but in reality, if you have like a piece of paper to like write it down, maybe like over here, you can just calculate all of that. So if you plug in 1, you get 1 minus 4 is negative 3 minus 5 is negative 8. If you plug in 2, it's going to be 4 minus 8, which is negative 4 minus 5, which is negative 9. If you plug in 3, it's going to be 9 minus 12, which is negative 3. Minus 5, which is negative 8. If you plug in 4, it's going to be 16 minus 16, which is 0, minus 5, negative 5. And finally, the 5 is going to be 25 minus 20, which is 5, and 5 minus 5 is 0. That's it. You plugged in basically all of them, and now it's time to put it over here. 0, negative 5. 2, 3, 4, 5. Closed circle. Why closed circle? This sign is a closed circle. And so is this sign is a closed circle. So it's going to be 0, negative 5, 1, negative 8, 2, negative 9, 3, negative 8, 4, negative 5, and 5, 0. And now I'm going to connect all of these points to the best I can. And again, you strictly are not allowed to go over the boundaries. And this is it. This you can technically put the equations, like let's say these functions next to these lines. Sometimes they make you do it, sometimes they don't. But the idea is that this is 4-point question, and this would be the full 4 points for this question. All right, I think we're going to do one more question and we'll be done. Okay. All right. This is a classic. I'm going to do separate videos for just these questions, because if you haven't been attending your Algebra 1 class at all, this is a type of question that I suggest you knowing how to do, because it's 4 points and it comes on every single region test. So in order to pass the regions, you need to collect like around 16, 17 points. And this would be a quarter of passing, just knowing how to do this type of question. So let's go ahead and do it. So we have to do 2 linear equations here, 2 linear inequalities. I like splitting them on both, like on 2 different sides of this paper. I always do that, so I won't mix them up. Step one, make sure that your inequality is in y equals mx plus b form, which the first one is not. But it's just one step away from it, right? All we have to do is just to move that 2x to after the inequality sign. So it's going to be y greater or equals to negative 2x plus 8. Step 2, graph it. How do you graph it? Well, if you know how to graph linears, you will know how to graph this. You go to the where y equals to 8, to the y-intercept, and then you use your slope negative 2 as down 2 and right, and 1 to the right, and 1 to the right. So down 2, 1 to the right, and put a point. Now, before connecting those 2 points, you need to know what kind of line you're going to connect it with, solid or dashed. Well, this sign is a solid line, and this sign, or this sign, right, is a dashed line. So we're going to use a solid line to connect. So I've seen them taking away points from students' work if you don't actually put this inequality on top of this. Or maybe you have to actually put the original one. I don't know. Depends who's checking your work. But this is what it is. Now the shading. This is the last part, because for the next one, we're just going to repeat the process. The last part is the shading. So how it's going to happen? How do I do the shading? I plug in 0, 0 for the x's. Like 0 here, and it's greater or equals to 8, and I want to find out whether it's true or not. So 0, it becomes 0 plus 0 is greater than 8. Is that true? Is that true? It's not true. Not true. If it's not true, you shade away from 0, 0. 0, 0 is here. So we're going to shade away from 0, 0. So it's going to be this way. Like, you cannot really go over, but it's okay. Let's say I didn't. Now, we're going to do the same process, but with another inequality. Same exact process. So technically, if you think about it, you need to only remember how to do one type of process and just repeat it twice. That's all. So it's going to be y. Let me do it a little bit thicker. So y minus 5 less than 3x. So I'm going to move the negative 5 to the right side, which is y less than 3x plus 5. And this is it. Now I'm ready to graph that. So how I'm going to graph that? I'm going to go to the 5. 1, 2, 3, 4, 5. Put a point there because of that, because of the y-intercept. And now I'm going to do 3. 3 is what? 3 is 3 over 1. Up 3, 1 to the right. Do it. And now I'm going to connect those 2 points. I don't need more. Some people put more points. I don't need more. Like, you can if you want. If you can just keep going down like this. But you don't have to. Officially, 2 points is enough. The only thing is that you're going to have to use the dashed line. So let's go. Boom, 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 boom. You have to be more accurate. You know, I'm doing it with the mouse on the computer. Now the shading. Let's plug in 0, 0 over here. 0 minus 5 less than 0. Negative 5 less than 0. Is that true? Yes, it is true. We shade towards 0, 0. This way. So everything towards 0, 0. And the spot where both shadings go on top of each other, it's called the solution set, which you can mark like that with the letter S. Maybe we should like put this y minus 5 is less than 3x over here. All right. This is it in terms of the graphing. This is 3 points already out of 4. And the last question, determine if the point 1, 8 is in the solution set. Explain your answer. 1, 8. 1, 1, 2, 3, 4, 5, 6, 7, 8. It's not in the solution set. It's not. Why not? If a point is on the dashed line, it is not in the solution set. As simple as that. If it's on the dashed line, it's not. If it would be on a solid line, it is. If it's anywhere within that region, it is in the solution set. If it's anywhere somewhere not in the solutions, anywhere else, here, 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 it's not. Only within, or it has to be on the solid. This is it. This is 4 points. So basically, knowing how to solve this question and the question before with the piecewise function, this is half of what you need to do to pass the Algebra 1 Regents test. So we're going to come back to this graphing the inequalities more. But for now, this would be it. So we're done for today for the Algebra 1.